Today we are going to discuss about simple harmonic motion, its differential equation and solution. So we know that there are two types of periodic motion. What is periodic motion? Periodic motion means a motion which repeats in regular intervals of time. So periodic motion, there are two types of periodic motion. First category is oscillation and the second category is vibration. So in periodic motion, if the body completely involves in oscillation, it is called oscillation. If some parts of the body involves in periodic motion, it is called vibration. So here we are going to discuss about one kind of oscillation. So in oscillation, body completely involves in periodic motion. Completely involves in periodic motion. This is called oscillation. So we can generally classify oscillation into three categories. The first category is simple harmonic motion. Okay, so in simple harmonic motion, if we oscillate a body from the extreme position, this is equilibrium position and this is extreme position. If you oscillate the body from the extreme position, it goes to the next extreme and comes back to the initial position. Then this body oscillates with constant amplitude. This is called the simple harmonic motion. So in simple harmonic motion, body oscillates with constant amplitude. What is constant amplitude? Amplitude means the distance from equilibrium position to the extreme position. That means this distance is constant throughout this motion. This distance is constant means this oscillation will never dies out, it oscillates continuously. This is called simple harmonic motion. The second category is damped harmonic motion. Damped harmonic motion means in this simple harmonic motion, if air resistance comes, what happens? Air resistance means which is a force which opposes the motion of this body. So due to air resistance, this is an oscillating body. When it is released from this extreme point, this is extreme point, that is x equal to a, it goes to the next extreme and comes back. So due to air resistance, this much distance reduced. From this point, second oscillation begins. It goes to this point. Then the oscillation decreases with time. When time increases, oscillation decreases and finally body comes back to the equilibrium position. This kind of oscillation is called damped harmonic motion. So by comparing these two, if simple harmonic motion, there is no air resistance. Okay, there is no air resistance. So the body oscillates with constant amplitude and this oscillation exists for a longer time. That means continuously oscillate this body. But when air resistance comes, due to the presence of air resistance, what happens? When air resistance comes to this oscillation, due to the presence of air resistance, amplitude begins to decrease with time. Okay, this is called damped harmonic motion. The third category, that is forced harmonic motion. So what is forced harmonic motion? Third category is forced harmonic motion. So in an oscillating body, when we release it from the extreme point, x equal to a, it goes to the next extreme and comes back to the initial position or from this position. When it reaches this point, we apply an external force. Okay, so under the influence of this external force, this body comes to the next extreme and comes back to the initial position. Again we applied the force, then it goes to the next extreme. Due to the presence of this force, it oscillates with constant amplitude. Okay, this is called forced harmonic motion. So in forced harmonic motion, amplitude is constant. Why this amplitude is constant? Due to the presence of this periodic force. Due to the presence of this force. Force means when it reaches this initial position, an external force is given to this body. Again it goes to the next extreme, comes back to the initial position. Again the force is given. So this force is repeating in regular intervals of time. This kind of force, if a force repeats in regular intervals of time, it is called a periodic force. So in forced harmonic motion, body oscillates with constant amplitude under the influence of this periodic force. This is called a forced harmonic motion. So this is the general classification of oscillation. There are three kinds of oscillations: simple harmonic motion, damped harmonic motion, forced harmonic motion. Simple harmonic motion, body oscillates with constant amplitude. This is the observation. In damped harmonic motion, amplitude is not constant due to the presence of air resistance. That is, when time increases, oscillation amplitude decreases and finally body comes back to the initial position or equilibrium position, or body is at rest. That is damped harmonic motion. Third category is forced harmonic motion. So in forced harmonic motion, under the influence of an external periodic force, body oscillates with constant amplitude. That means this force helps to overcome this air resistance. This is called forced harmonic motion. So these are the three observations or three types of oscillations. Then we have to derive the mathematical equation which represent these three motions. That is the differential equation of simple harmonic motion. First we are going to derive the differential equation of simple harmonic motion and its solution. So we are going to derive the differential equation of simple harmonic motion. For derivation, we have to consider a condition where simple harmonic motion occurs. So simple harmonic motion means if the motion begins, it oscillates continuously with constant amplitude. That are the two conditions for simple harmonic motion. The first point is body oscillates with constant amplitude. Oscillate with constant amplitude. Second point, body oscillates continuously. Body oscillates continuously. So these two are the two conditions for simple harmonic motion. So from the mathematical equation, we have to explain, or we can generalize these two conditions. So to derive the simple harmonic motion, equation of simple harmonic motion, we consider a body which executes the simple harmonic motion. So first we take a spring and a mass is suspended to the spring. Okay. Then this spring mass system, which is kept in a frictionless plane. Frictionless plane. So this spring mass system, which is kept in a frictionless plane, what happens when this mass is suspended to the spring? This mass elongates in the downward direction. So it elongates in the downward direction, and x is the displacement of this body when it is suspended in the spring. So what's the tendency of the spring? This tendency of the spring is to compress. Tendency of the spring is to compress nature. So the force acting on the spring, it is in the upward direction. Okay. So here we consider a spring mass system which is kept in a frictionless plane. If the spring mass system is kept in a frictionless plane, this body oscillates continuously with constant amplitude. Frictionless plane means there is no friction, there is no air resistance. That means it is vacuum. Okay. So this body oscillates continuously. What's the tendency of the spring? The force acting on the spring, it is in the upward direction. It is balanced with this displacement. Okay. So we can write from these conditions, we can write the force acting on the spring, which is proportional to the displacement of the mass suspended. But here force is in the upward direction and the displacement is in the downward direction. So we can put a minus sign. Okay, so this force is due to inertia and this force is the displacement. This displacement is due to this force. Okay, so F is proportional to minus x. So to change the proportionality symbol, we can multiply it with a constant k, minus k into x. Then according to Newton's law, we know that F is equal to ma, mass into acceleration. So ma is equal to minus kx since F is equal to ma. Okay, then we know that acceleration. What is acceleration? Acceleration is equal to rate of change of velocity, that is dv by dt. What is velocity? Velocity is equal to rate of change of displacement. Therefore, we can rewrite acceleration in terms of displacement d by dt of what is v? Dx by dt. Substitute the value of v here, dx by dt. So we get it is equal to d square x by dt square. So we can rewrite A as m into d square x by dt square. That is equal to minus kx. Then m into d square x by dt square. Take this term to this LHS plus kx, that is equal to 0. Then dividing by m throughout this equation, dividing by m, we get d square x by dt square plus k by m into x equal to 0. Okay, then we can make a substitution here. D square x by dt square plus k by m. This k by m, what is k? K is the force constant here and m is the mass suspended. So we can write k by m is equal to omega 0 square. So d square x by dt square plus omega 0 square x equal to 0. K is a constant, m is another constant. The value of this k by m, which is equal to another constant, it is equal to square of the angular frequency. So this is the differential equation of simple harmonic motion. Okay, so to derive simple harmonic motion, we create a situation which occurs where simple harmonic motion occurs. For this, we consider a spring mass system which is kept in a frictionless plane. So in frictionless plane, there is no air resistance or there is no frictional force. So this body oscillates continuously. So this is a case where simple harmonic motion occurs. So the tendency of the spring is the force acting on the spring is in the upward direction. So it will compress. But when mass is suspended, it elongates a distance x or displacement x in the downward direction. So from these two conditions, we can write the force due to inertia. This is inertial force. So F, which is proportional to the displacement. But here these two are in the opposite direction. So we can put a minus sign. So to change the minus sign, F is equal to minus kx. So to change the proportionality symbol, multiplied with a constant k. Then we know that F is equal to ma is equal to minus kx, m into d square x. Acceleration is equal to d square x by dt square, that is equal to minus kx. Then take minus kx into the LHS. So m into d square x by dt square plus kx is equal to 0. Then dividing by m. When dividing by m, we get d square x by dt square plus k by m into x equal to 0. K is a constant, m is another constant. So their fraction is also another constant. So we substitute d square x by dt square plus omega 0 square x equal to 0. This is the differential equation of simple harmonic motion. Okay. So what's the meaning of this equation? From this equation, we can generalize these two conditions. Body oscillate with constant amplitude or body oscillate continuously. But from this equation, we can state two conditions. That is, x is varying continuously with respect to time and the motion depends on a constant omega 0. This is a second order differential equation. But from this equation, we cannot state amplitude is constant or body oscillate continuously. So to explain these two conditions, we solve this equation, and by solving this equation we get the solution of this. This is a second order differential equation in terms of x. Okay, so by solving this equation we get x equal to a sin omega t plus phi. So this is the solution of simple harmonic motion. Okay, so there are two terms, a into sin omega t plus phi. What is a? A is the amplitude. So amplitude, it is a single term, so we can state that amplitude is constant. Amplitude is constant. So we get the first condition, constant amplitude, because there is no term associated with this a. Okay, then the second term is sin omega t plus phi. What's the meaning of sine function? We know that sine wave. Sine wave means this is a sine wave. Okay, if we consider this as the initial position, if an oscillating body oscillates from this position, it goes to one extreme, then goes to the next extreme position. Okay, then comes back to the initial position. Again goes to the first extreme, the second extreme, then initial position. So this signal or this sine wave represent this motion, the motion of this particle, which repeats in regular intervals of time. That means a periodic function. So in a mathematical equation, if sine function is there, what's the meaning of that? That function is periodic or oscillatory. Periodic means that function repeats in regular intervals of time. Okay, so if sine function or cos function is there, what's the meaning of cos function? Cos function means the motion starts from negative half cycle. This is a cos wave. Okay, in this cos wave also body repeats in regular intervals of time. So the presence of sine wave and cos wave indicates that function, mathematical function, is periodic in nature. So from this second term we can state that body oscillate. Oscillate means that is periodic. If a motion is periodic, then we can state that it is either oscillation or vibration. But here the body completely involves in periodic motion. So the body oscillate with constant amplitude. If amplitude is constant, what is the result? Body oscillate continuously. Okay, so this is the differential equation of simple harmonic motion, and by solving this equation we get x equal to a sin omega t plus phi. A is the amplitude. Amplitude is constant because it is a single term, so we can state that amplitude is constant in simple harmonic motion. Then what is second term? Sin omega t plus phi. What is the presence of sine function indicates? Sine function indicates that particle or that body repeats in regular intervals of time. That motion repeats in regular intervals of time. That is called a periodic motion. So we can state that body oscillate. Here the motion is oscillation due to the presence of sine function. Okay, so from the solution we can generalize these two conditions. Body oscillate with constant amplitude. If the oscillation is oscillate with constant amplitude, body oscillate continuously. Okay.